Hello everyone, good afternoon. I'm so happy to be a part of this webinar. So, as you all know, like we are going to see one of the feature selection technique, right? So, before going to the topic, let me just have a general discussion about feature selection. So, I hope you would be knowing about feature selection, right? So, what is exactly feature selection? So, I want this to be an interactive session. So, you can just put your inputs. So feature selection is one of the important step in data science workflow, right? So what exactly feature selection is? Reduce the number of inputs, going to algorithm, exactly Prasad. Right. Okay. So as I told, feature selection is very important step when it comes to high dimensional data, right? So in the real time scenario, we will be mostly working with high dimensional data, right? So where we would be having more number of features. So what exactly what could be the drawbacks when we are working with high dimensional data? The training time would be increasing, right? And the model's complexity would be increasing, right? It's very hard to interpret, right? There are certain drawbacks when you have more number of dimensions. There could be possibility for having redundant data, right? So when you pass a redundant data to the model, how the performance is going to be? Obviously, you're not going to get accurate prediction, right? So it is very important to give proper data or right features to the model to have the better result or better prediction, right? So that case, feature selection becomes very important, right? Where when I say feature selection, it is nothing but you're going to get a subset of relevant features, right? So we are going to see about one of a technique which we can use for feature selection. I hope my screen is visible. Can I get a confirmation? Thank you, Prasad. Thank you all. Okay. So when I say feature selection, it is nothing but we are going to get a subset of relevant features to train the model. Okay. So how we are going to do that? So when I say relevant features, we are going to remove the redundant data from our data set, right? So that could obviously improve the model's performance. When you are removing the redundant data, obviously you're going to get a good performance, right? And your training time is going to decrease, right? And obviously you can reduce the overfitting. So there are certain advantages of doing feature selection. So you're going to reduce the time taken for training the model, right? And when you remove the redundant data, obviously you're going to get better result or better prediction, right? These are all the advantages of feature selection, doing feature selection, right? You can reduce the overfitting, right? And you can reduce the complexity of the model. So if you already in the journey of data science, you must be knowing how important feature selection is, right? And you must have explored on certain techniques for doing feature selection, right? So there are several techniques for doing feature selection. So there are wrapper method. You can do feature selection using wrapper method. You can do it using filter method. We have embedded method. There are several ways to do feature selection, okay? So we are going to explore on feature selection using wrapper method today. Okay. So let's go into the session. So let's talk about feature selection using wrapper method. So in wrapper method, we will try to use a subset of features and we are going to train the model using those subset. Okay. So here it will try to get it is going to train the model with the subset of features that it has identified. So let us see how it is going to get the subset of features. So obviously when it gets subset, it is going to be the relevant or the important features. Okay. So this wrapper method will take all the features. It will get the combination of the features to find the performance of the model. Okay. So again, there are a few methods in wrapper where we will look into each type first. So here basically it will not take all the features. It will take a subset of features by identifying which could be the relevant features by taking each subset of features, and it will train the model and it will check the performance. Whichever combination is going to give you the best performance, that features will be taken for final to create the model. Okay, so let us see the types of wrapper method and let us discuss how each type will work. So here we have forward selection, forward feature selection, we have backward elimination method, and we have exhaustive feature selection method. The concept behind these methods are very simple. Okay, so basically wrapper method is going to take all the combination, all possible combination, and it is going to means combination of features, and it is going to train the model and see how the model is performing for each combination. Okay, so first let us look into forward feature selection. Let me take it in another page. So let's say I have 4 features. Let's take F1, F2, F3, F4, and we have Y. Okay, so these are the input features we have in our data set. When we apply forward feature selection to our data set, it is going to take several iterations. In each iteration, it is going to check, it will take each feature and it will check how the model is performing. Let's say in the first iteration, it is taking F1. F1 and Y, it feeds to the model, the first model. Okay, the model is getting trained on this F1 feature, and it is going to evaluate the model. So you can take any model here based on what business case you have. When you are solving a regression task, you can take regression algorithms. When you are taking classification tasks, you can take classification algorithms. Okay, so it is going to evaluate the model, get the score. In first iteration, it will take each feature to find out which feature is best here. Okay, so it will get the score. So let's assume that we get good score with this feature. Okay, so by training the model with each feature, it has identified good score for feature 3. So in the second iteration, it will take F3, the third feature, and it is going to check with the combination with this F3 with all other features now. Okay, so in the second iteration, it will check with the next features. It is going to take two features and will check how the model is performing. So with F3, it will check feature 1 and feature 3 and train the model and will get the score. Similarly, it is going to check the combination with other features like F3, F2, F3, F4 and will get the score. So it will train the model with these two features now and will check the score and see where we are getting good score. Okay, let's assume that this is giving a good score. Okay, then in the third iteration, these two features are selected and along with these features, it is going to again check with other features. So here it will take F1 and train the model and check the score. And now it is going to take the other feature, which is F2, train the model and get the score. Okay, so now it will see which performance is good. So those features will be taken as the relevant features. Okay, so this step will be continued until we reach desired number of features. Okay, so in forward feature selection, iteratively it will take each feature, get the combinations and find out which combination is going to give you good score. Those features will be selected as the right feature. Okay, and this process will stop until we get desired number of features. So let's say when you have 100 features, okay, so it will try with single feature first, find out which feature is right feature. Okay, that feature it is going to see. Whichever feature is going to give you good performance, that feature will be taken, and with that feature it is going to check the combination with other features to find out which combination is going to give the best score. Okay, so in each iteration it is going to keep adding one feature and see the score. Okay, so by adding each feature at each iteration, it will find out which combination gives the best score to select the subset, the right subset of features for training the model. Okay, so let's say in this case, if we have got a good score here, then it will take F3, F4 and F2 will train the model. Okay, we can create a model with these features, okay, and train the model to get the better score or better accuracy. Okay, this is how forward feature selection works. Okay, so let's say when you have 100 features and you wanted to have, let's say 20 features from it. So until we get 20 important features, this process will be done. Okay, it is going to keep on adding one features until it gets the first 20 important features, and it will give you the best 20 features for creating the model. So this is how forward feature selection works. Okay, any doubts here? Okay, so let's talk about the next technique, which is backward elimination method. So in backward elimination method, this is just exact opposite of Any guesses? Opposite of forward feature selection. In forward feature selection, you're going to add one feature for each iteration, and you're going to check which feature is giving. How do we select how many feature we wanted for? Yes, exactly, Vivek. We are going to tell how many features we require. Okay. In all these techniques, we are going to tell how many features we require from our data set. Okay. So it will select, let's say if I want 10 features, the top 10 features will be given by these techniques. Okay. So in this case, if you see, we have 4 features. If the desired number of features, if I have given it as 3, okay, then this is the 3 of, this is a subset where I have 3 number of features. Okay. If I give it as 2, then this will be the final subset of features that the technique is going to give me. So this backward elimination method is just exact opposite of forward feature selection. In forward feature selection, you keep adding one feature for each iteration. Right? But in backward elimination, we are going to take the entire subset, entire set of features, and each iteration it is just going to remove one feature and see where we are getting good performance. The entire set of features will be taken and it will remove one feature in each iteration. So let's say if we have 5 features, F1, F2, and you have 1. So here it will take all the features. Okay. We'll train the model. And in this first iteration, it's not going to take, it will not train the model. First, it will take any one feature out of this set. Okay. So here, let's say it takes F1, F2, F3, and F4. And takes Y, train the model. And get the score. And here, let's say if it takes F2, F3, let's take. Now it removes F4 and takes Fy and see how the model is performing. So it will try removing one feature and see where it is getting good score. So when which feature is removed, we are getting good score. Okay, it will check that. So here F5. So similarly, it will remove one feature from this and it will check how the score is. So let's say in here we are getting good score. Okay, so for the next iteration, this is for first iteration. In the second iteration, it is going to take this. From here, it will remove one feature. So let's say if it removes F5 here, F1, F2, F3. And from this, it will try to remove other feature now and train the model. Let's say F1, F3, and F5. F2, F3, and F5. So these are the possible combinations, right? It will try with these combinations and will train the model. Okay. So let's say in this, we are getting good score on this. Then this combination will be taken for the next iteration. In the next iteration, it will remove any one feature from this and find out which is giving good performance. Okay. So here, if the number of features we have asked is 2, let's say we want, out of this, we want only 2 important features. Then it will try until we get the 2 features from this. So here we have 3 features. So again, it will try removing 1 feature from this and find out which is giving good performance. So F1 and F3, sorry, F2 and F3, then F2 and F5. These are the possible combinations it can have, right? F3 and F5, right? And it will check which feature is giving good score. Okay. So let's say if we are getting good score on this, then this will be the final subset of features to train the model. F2, F5 is going to be the optimal features to train the model. So we can create a model with these features now. Okay. So in backward elimination method, it is just going to remove 1 feature in each iteration to check which combination is giving me a good score, or when which feature, when which feature is removed on our subset in our set, it is giving you good score. Okay, it will identify that and it is going to give us the right features for feeding the model. Okay, so in forward selection, we keep adding one feature in each iteration to check when I get the good score. Okay, which feature is added on our subset, we get a good score that we can see. In backward elimination, it is just going to remove one feature for each iteration and find out finally which features are going to give good score. So those features will be given by the technique for creating the model. Is this clear? Any doubts? Okay. How many things will happen if we want to solve unsupervised data clustering? No, Prasad. This you can use for classification and regression. Will this feature be same as forward feature selection? Vivek, it is going to identify which feature will be important when you remove the features, right? It might give you the same features like your forward feature selection, or you might have different features also. Let's see in the implementation and you will understand, okay, how whether it is giving you the same features or whether it's giving you different features. It depends on the data set, right? So we will see that in the implementation. So the next method is exhaustive feature selection method. So this uses a greedy search algorithm. So you might be knowing what is greedy search algorithm, right? It is going to try with all the combinations, not like a forward feature selection or backward feature selection. So let's say if you have three features. So first it will try with F1, it will try with F2, it will try with F3, means it is going to take single features, it will take the combination of 2 features, Then it will take the combination of 3 features. It will try all the combinations to check where our model is performing good. Now it will take F1 and F2 and train the model. Then it will take F2. With F1, it will take F3 and train the model. Then F2 and F3 will be taken to train the model. Okay. And it will take all 3 and we'll see. So here we have less number of less number of features. Imagine if you have more number of features. Let's say if you have 10 features or 20 features, it is going to try with all the combination. Okay. It will try with single feature, it will try with 2 features, it will try with 3 features, it will try with 4 features. Okay. It keeps on going, until it takes all the features and check the model where it is performing well, means with which combination it is performing well. That combination will be taken as the optimal features for creating the model. So it is called as greedy search algorithm. It uses greedy search algorithm. Okay. So you can imagine when you have 20 features, how many combinations you are going to have, right? And you can imagine how much training time or how much time it would take to find the optimal features, right? So it takes a lot of time, and it is obviously it will give you a good score, good features, right? When compared to other two, but it takes bit time. Okay, so computationally, it is going to take more resources to use this method. That is one disadvantage of this. Okay, so here it is going to check with all the combination to find the right features for creating the subset. Okay, so here it will try with all the combinations of features. Okay, so finally whichever is giving you good score, that will be taken as the subset. So let's imagine if we are getting good score here, then these will be the final features taken for training the model. Okay, so you can tell how many combinations can be used. Let's say if you have 100 features, you can tell how many minimum features should be taken for the combination. Let's say if minimum features should be 5, then it will start with 5 set of features. Minimum, the combination will be taken with 5 set of features, and it is not going to check with single feature or with the 2 features or with 3 features or with 4 features. It will start from 5 set of features in the combination, and you can tell the maximum limit also. You can tell minimum number of features to be taken, and you can tell the maximum number of features has to be taken. Okay, so from there only it will take the combinations. If you give us 3, it will start trying with 3 combination. It will, if you give us 4, then it will start taking the combination with 4 set of features. Okay, so from 4 it will try till the maximum number of features that you have given. Okay, so let's say if you give 20 features, then it will try with 4 combination, 5 combinations, 6 combinations, until 20 combination of features. It will check all possible combination. It will check from 4 to 20, and in this it will find out where we are getting good score. Okay, those features will be finally given by this method for creating the model. Okay, so this is how exhaustive feature selection method works. So it is just going to try with all possible combination of features to get the optimal features. Is this clear? Any doubts here? So we will see the implementation of this. Okay. I hope you have got the link for downloading the file. Just a moment. Shubhangi, should we send the link? Should we share the link here? Let me share my screen. Have you got the link to download this file? Can someone confirm? Not yet, is it? Okay, I'll share the link. Or I'll ask Shubhangi 1 second. Okay, so link will be shared here. Okay, until then I'll just go through this. I'll just explain you this. You can try after the session as well. Okay, yeah, link is shared. So kindly download that. So let us see how to apply these techniques here. So let us first import all the packages. So here we have taken one data set for which we are going to do feature selection using these techniques, and we will see the difference. Okay. So we have taken admission prediction data set here. So these are the features we have. Okay, we have GRE score, TOEFL score, university rating. So these, based on these features, we are going to predict what would be the chance of admission for each student, right? So chance of admit is going to be the target variable here. So here, just simple pre-processing we have done. We are going to rename all these features. So as you can see, we have only numerical features here. So pre-processing, not much pre-processing we are going to do here. We will just find out if we have any missing values. So we have certain missing values. So that here I have done, imputation. So basically, university rating is a discrete value. So I have taken mode, and for other features, it is continuous. So I have calculated mean, and I'm going to replace the missing values with mean and mode. I hope these are familiar for you. I hope you can do it. So we have imputed all the missing values. So since the session is about feature selection, so let us straight away go to the implementation of these techniques. Okay. So first, before applying these techniques, first let us create a model, okay, by taking all the features. So in this, except serial number, which is a unique feature, right? We are not going to take this. Rest all other features let us take, and let us create a model. Okay, so this is a regression task, right? Chance of admission, where you are going to check the probability of the chance for getting admission, right? So this is a regression task. So let us take one regressor. So here I am taking random forest regressor. Okay, so this is a model I'm going to use, and first I'll take all the features. Okay, except target features, I'm assigning all that as X and taking the chance of admit, which is a target variable, as Y. And let's do the train test split. So with all the features, let's train the model just for the comparison. Okay. So here I'm doing a train test split, initial importing the model, random forest regressor, and initializing it with number of estimator as 100. So you know number of estimators, nothing but the model, right? It is an ensemble technique, so it is going to combine multiple models, right? So I have initialized the random forest regressor with 100 base models, and let's train the model and let us do the prediction. Okay, so these are all the regular usual steps that we will do, right? So with all the features, we are going to train the model and let's check the score. So here I'm going to use R2 score metric to evaluate the model. So by taking all the features, we have got 78%. Okay, and also let's check for the adjusted R2 score. So I hope you know the formula for adjusted R2 score, right? So we have got 77% as adjusted R2 score. This is by taking all the features. Okay, now let us take the subset of features using these techniques. So first let us apply forward feature selection method. So for this you have to import or install ML extend library. Okay, so from this library, so you have to install it. I have already done, so I'm not going to do it now. You can install this library. So from here we are going to import sequential feature selector. Okay, so we can use this sequential feature selection to select the feature sequentially. So in these techniques, we are going to try with each feature by adding it sequentially, right? So this particular method is, this particular algorithm is going to be used. So we are going to import that from feature selection from ML extend library. Okay. So you can install this. Okay. So these methods will use some algorithm to evaluate the performance of the model by taking each subset of features, right? So what algorithms you can use? So you can use, if it is a regression task, you can use any regression algorithm and you can check for each subset of feature how the model is performing. Okay, so here again we have taken random forest regressor. Okay, so let us import that. Okay, we have already imported it, so this is not required. So first let us import sequential feature selector from ML extend library and let's initialize it by using some algorithm. So here we have taken random forest regressor and we have to tell how many number of features we require. So how many features we have totally in the data set. So we have 1, 2, 3, 4, 5, 6, 7. 7 independent variables. So out of 7, I wanted 5. So I'm using this k underscore feature parameter where I'm telling how many number of features I require. Okay. And forward parameter here I should give as true if I wanted to apply forward feature selection. If it is going to be backward elimination method, then for this parameter, I will pass it as false. Okay. And the cross validation, how many number of folds has to be used, and end and underscore jobs will tell you how many cores should be used, the processor should be used, and which scoring, which parameter evaluation metric has to be used. Okay. So again, I have given us R2. Based on R2 metric, it is going to evaluate this model with different set of features. Okay. So let us first define our X and Y. Let us apply this sequential feature selection on the model with different subset of features and let's train the model. So now our model got trained, and if I want to know which features have been selected finally, okay, so I can use k underscore feature underscore names command to get the features that have been selected. So since I have told 5 features I require, it has given me 5 features, the optimal features for creating the model. Okay, these 5 feature combination have given the good score. It has tried with all the combinations, and these are the features that it has selected. Okay, so this k underscore feature underscore index is going to give you the index of these features. If you just check into the data set, you can see 0 is for GRE score, the index of TOEFL score is 1, the index of SOP is 3. So this will give you the index of the features, the selected features, and this will give you the names of the selected features. Okay, so if I want to know what is the score for each feature that it has selected, okay, each combination it has selected, so you can check it by using this method, get underscore metric underscore dictionary. Okay, so you can see for each iteration what is the performance it has got. So first it has identified the index 5 feature. Whatever feature is in index 5, that has been given the good performance. So that feature is selected first. With that feature, it has checked with all the combinations with other features. And in that, it has identified 0 and 5 gives you the good score. Okay, then it has taken these 2 features and it has tried with the other features, okay, to see where it is getting the good performance. So for each combination, it has identified these are the optimal features. Finally, this is going to be the features it has selected as the important features where it is getting good score. Okay. So now what we can do, we have got the optimal features. Now let us create a model with these features. So I have taken these 5 features. Let me once again check it. I've got GRE, TOEFL, SOP, LOR, and CGPA. So instead of research, I should have TOEFL here. So let's create a model with these features and see how our model is performing. Okay, so all these features I have taken as X and the target variable as Y, and let us initialize the model, and we are going to train the model with these features. Okay, so before that I'm doing train test split, and we are calculating the R2 score for this model with these features. So we have got 78. So if we see the previous one also, we have got the same score, right? Which is 78 when we have all the features. So it depends on the data set as well. Okay. And you can really compare when you have, you will be having difference when you have more number of features. When you're working with a high dimensional data, you could see the difference. So let us also check the adjusted R2 score. So which is again 77. I think the same we have got for the previous model with all the features. It is 77. Okay. So in forward feature selection, it is going to keep adding one feature in each iteration, and in that it is checking which combination is giving good score, and it tries by taking those features from the previous iteration and again creates a combination with all other features, and again in each iteration it is finding the good optimal features, and finally how many our features we are asking, those many features will be given as the optimal features. Okay. So now we have tried with forward feature selection. Let us also see how backward elimination works. So any doubts here? Simple concept behind these methods. Okay, let's try with backward elimination. So again, the same function we have. In this, we are going to give forward as false to have the backward elimination. Okay, so we are initializing this sequential feature selection, and where we are passing the model and telling here I want 4 number of features. Okay, so forward I should give as false to have the backward elimination, and the rest all other remains same. Okay, again using R2 score for evaluating the model, and let's train the model. Where you are getting error? So we have trained the model, and let us see which features have been identified as the optimal features. So these are the index of those features. Let us see the name. So we have GRE score, SOP, LOR, and CGPA. So if you can see here, forward feature selection has given different set, right? And backward elimination has given us different subset of features. Okay. So these features we have taken. Let us see the score. So we have asked for 4 number of features, right? So it is checking till 4 features, and 77 is the average score for this combination. Okay. So now let us take these features and let us create a model. So we have taken GRE score, so university rating, SOP, LOR, and CGPA. So these are the features we have taken. Let's create a model with these features now. Okay, so let us take all this as our X and target variable as Y, and let us do the train test split, and let us initialize a model with 100 base learners, and let's train the model with the training data, and let's check the R2 score. So here R2 score has reduced, right? Earlier we got 78, and here we are getting 77. So for these features, but according to backward elimination method, whatever features it has given, right, these are the optimal features based on this technique. Let us check the adjusted R2 score, which is 76%. So this is also reduced, right? So you can see that different method is giving you different score, right? Okay, so adjusted R2 score, I should give as number of predicted as 4 because I have taken 4 features. Let us check. So again, it is 76. Okay. So this is how backward elimination works. So this parameter you have to change if you want backward elimination method. Okay. So that's the only difference here. But you can see that it is giving you different set of subset, different subset of features, and you can see the performance, the difference in the performance as well. Right? And let us take the exhaustive feature selection as well. Let us see. So exhaustive feature selection, again, we are importing it from a feature underscore selection. Okay. So here, this is not going to work. This is not going to add feature sequential manner, right? It is going to check with all the combinations. So we have a different algorithm here. Okay. So this is the algorithm which we are going to use. Let us import it from feature selection, and let us initialize it with a model, with the algorithm. Okay, so here you can tell how many features, minimum features to be taken for combination, and the maximum number of features to be taken for the combination. So it will try only with from 2 to 5 combination of features. Okay. So again, we are taking R to score as a metric for evaluating the model. Let us train the model and find out which is going to be the optimal feature. So this takes bit time than the other methods, because as you know, here it is going to try with all the combinations, right? Since it is trying with all the combinations, it is a bit complex. Okay, but you're going to get a good score on this, because really it is trying with all the features. So obviously you will get the right features from this method, but it is computationally expensive. So we have trained the model. Let us see what features this has given. So we are getting as GRE score, TOEFL score, SOP/LOR, and CGPA. These are the features this technique has identified. Let's check the score. So as you can see, it is trying with two features. As we have given minimum features as 2 and maximum features has 5, it is trying only till 5 features. Okay. So in this, it has identified these features where we are getting good score. So these are the optimal features we are getting from this technique. Let us create a model now using these features. So what are the features we have? Let us just copy and paste it for our X. Let me give it here. So these are the features we have taken, which are the optimal features. And let's do the train test split and initialize a model. And let's train the model. So this has given 77%. And 76 as adjusted RT score. Okay, which is same as backward, right? In backward elimination, we have got RT score as 77 and adjusted RT score as 76, right? So only in forward feature selection, we have got good score, right? So you can compare by having all these method, okay, and see where you are getting good score. So that technique you can use to get the optimal features. So based on exhaustive feature selection, these are the optimal features that it has identified by trying with all the combinations. Okay, so this is how we can use these methods to find the right features to creating the subset. Okay, so when you try to increase the number of features, obviously your training time is going to reduce, right? And if you're taking the relevant features, you can improve the performance of the model, right? When you have redundant data in your data set, obviously your model is going to will not perform good, right? So when you have right features, your model is going to perform good. So this is very important step in your data science workflow. Okay, so you can use any technique and see how your model is performing. So this is one technique where you can use for feature selection to reduce the number of features. So when you work with a high dimensional data, these techniques are really useful to find the optimal features. Okay. So any doubts here? So try using this technique for your projects and see whether you can also try with other methods. So you need to explore find out what all feature selection methods we have, okay, and try to utilize all these techniques, okay, when you do the project. So if you have any doubts, you can post it, or if you want to ask, you can ask. You can raise your hand. So I hope this session was useful for you. So try implementing this. Okay then. So fine. So I'm glad to have this opportunity, and hope the session was useful for you. Okay. So happy learning, and keep learning new concepts every day. Okay. Fine. So I'll end the session. If you have no doubts, thank you all. You have been a great listener. Thank you all very much.